So to start talking about equilibrium, we need to talk about reversible reactions. So a reversible reaction just means that reactions can occur two ways. If we think of liquid turning into a gas, so this is just water boiling. Reaction happens that direction, but we can also turn it from a gas back into a liquid, so right at that direction. This is referred to as a reversible reaction. If you boil water, you can condense it back into a gas or liquid. Same thing with dissolving. If you've got a solid, you can dissolve it, and if you boil off the water, you can turn the aqueous into a solid. Reversible reactions. And many, if not all, reactions are reversible to some degree. You put in enough energy, you can get a reaction to go backwards. So up to this point, we've always talked about reactions as if they're completion reactions, which means that if you've got a certain amount of reactants, all of it will turn into products. And so we draw it with just a one-way arrow indicating that, hey, it just goes that direction, and that is it. But it doesn't always occur this way. Not always do the reactants form the products, and that's it. Sometimes the products will also form the reactants in the same vessel. We call this process dynamic equilibrium. Dynamic because it's constantly moving. So most reactions do not actually go to completion. Instead, the reactants, so in this case dinitrogen pentoxide or tetroxide, are going to react to form two nitrogen dioxides. But those two nitrogen dioxides are also going to react to form dinitrogen tetroxide. And so we have this two-way arrow indicating that this reaction is actually occurring both ways. So, as it's written, this side would be our reactants, and this side would be the products. But in all actuality, the reactants and products are really the same thing. Just depends on which direction you read the reaction. Both reactants, and they're both products. And this is constantly happening. So as these are turning to that, those are turning back, and we get that dynamic equilibrium where it's constantly moving back and forth. Here we can look at a little graph that shows this process. So if we're starting with our dinitrogen tetroxide and 0 of the NO2, so as time goes on, this is going to decrease and this right here will increase. And we see that this line is a lot steeper than this line, and that's because we have 2 NO2s for every one of these. And so for every one of these that disappears, we're going to produce 2 of those. And so it'll be double the rate going on here. And eventually, as time goes on though, we form and it levels off. So what we see is not all of the N2O4 disappears. It doesn't all get used up because eventually we set up that dynamic equilibrium where both of these are in the reaction vessel, constantly moving back and forth. And if we look at the rate versus time, so at first this is the rate of this disappearing. It's fairly slow. This is appearing pretty quickly because for every one of these, 2 of these will appear. And so it'll eventually hit the point where it reaches that state of constant rate of reaction, and that would be what we call equilibrium. So here's just some of the concepts surrounding equilibrium. All of these are going to be important, and it's important that you understand what equilibrium is. We're going to talk next about equations. Don't get yourself tied up in those equations without really understanding what's going on.